Hi, my name is Tchaas Alexander-Wright. This is my literature review for the project, a cognitive science look at why object-oriented programming is so much harder than it needs to be for neurodivergent learners. Working memory holds about 7 chunks of information at a time. Learning OOP means tracking syntax and program logic simultaneously, which eats up at the capacity fast. For neurodivergent learners, that cost lands hardest at 3 specific moments: learning syntax, the jump to writing a full program, and debugging. My research question is, how much do schema-driven and visual supports actually reduce cognitive barriers for neurodivergent programmers? I ground this in the computational representation understanding of mind using 3 cognitive science lenses: mental schemas, which explain how we chunk information; analogical thinking, which highlights how we solve new problems from the past examples; and distributed cognition, which explains how tools outside the brain can carry part of the thinking. I've built the review in 2 passes, starting from the core readings from Sweller, Simon, and Thangard, and explaining by tracing citations and searching Google Scholar, IEE Explorer, the AMC Digital Library, and PubMed. This produced 16 peer-reviewed sources discussing human factors, computing, clinical psychology, and CS education. The clearest pattern: heavy text environments don't cost all learners equally. For ADHD learners, it shows up as attention fatigue and trouble getting started. For autistic learners, it is different because their systemized strength gets blocked, not weakened, because the plain text hides the structures they're good at spotting. Most studies still lump both into one generic novice programmer category. Visual-based scaffolds help at every stage. Block-based tools measurably lowers syntax errors. UML diagrams cut down on blank page paralysis. And at debugging, the example that is on the screen is the same bug but looks completely different depending on how it is shown. Traditional text-based output is a stacked trace of several lines before you find the fault. Schema-driven visual representation displays the same error as a geometric break in an otherwise uniform pattern that is spotted at glance. Hutchinson distributed cognition framework ties this together. The coding environment itself should act as the material anchor that is carrying the mental state outside of the learner's head. But there is one open issue. Block-based tools remove syntax load, but hides exactly what the programmers eventually need for real programming pointers and memory management. Nobody has shown a proven bridge yet. There are 3 practical solutions. For educators, making UML diagramming a required first step and not optional extra. For IDE developers, treat features like a live dependency graph and persistent class visuals as cognitive load tools, but not cosmetic ones. For accessibility policy, shift from accommodating students after the fact and toward the universal design built into the instruction. A few real limitations. Most studies don't separate ADHD from autism, which hides who needs the support. The evidence is mostly high level with no real eye tracking or step-by-step data on working memory during visual block work. And nobody has shown these tools scaling to industry standards yet, and all 3 are natural first steps. The key takeaway is how code is represented is not a decoration, but a cognitive design choice. Schema-driven visuals let the IDE carry out the mental load that neurodivergent learners otherwise carry out entirely alone.